All right. We are going to talk about two-step molar conversions. The other day we did one step, so now we're working on two-step. Looking at the flow chart we drew last week, so you should be on this page, and beside the steps where you got some open space on the right, redraw your flow chart. What's in the middle?
Moles.
Moles, yes.
Grams is on the left.
Yep, and then grams on the left. And then Pam on the right. What does Pam stand for?
Particles.
Atoms.
Yes, and remember my top arrows go out, just like eyebrows. They're pointing outward. And then grams point inward. All right? And how do I convert between moles and Pam?
Multiply.
How many molecules are in one mole?
Oh, 6.02
times 10 to the 23rd.
Yes, or E, 23. All right? 6.02 E, 23. And grams and moles, what's the base for grams? Molar mass. Yes, the molar mass of the molecule. So it just depends, whatever you're dealing with. Molar mass of molecule.
Can you just write that as MMM?
If you know what that means, sure. All right. So using this, today we are going to look at potentially one path option would be going grams to moles. And then going moles to Pam. So my conversion would be I've got grams and I need to go to molecules, for instance. All right, so two steps. We got to use mole as a bridge to get there. All right, so let's look at the first example in your notes. Calculate the number of, what do they want me to find?
Number of molecules.
Molecules. In, what did they give me?
Gram.
Grams. That's my given of hydrogen sulfate. Right, so first we need to know what hydrogen sulfate is, right? Because I need to be able to calculate the mass because I know it says, oh, it says grams. I'm going to need the molar mass. Hydrogen, this goes back to naming, plus 1. SO4, what's the charge of SO4?
-2.
-2. And then when I swap and drop, so I bring my 2 down here, my 1 over here, I have H2 SO4. So just a quick review. Why did I get rid of parentheses? There was a 1 outside. Do I need it? No. All right, so quick review on naming if you got stuck on that. All right, so this is your given and your find. You've identified that. And here's the path we're going to take on your flow chart. All right, we're going from grams. We need to divide by the molar mass to get to moles. And then I can convert moles to Pam. All right, same exact process as you were following the other day. However, now they're just tailing onto each other. So I need to first find what?
No mass. Well, average.
If I have my table here, what always goes in my top left corner?
What you were given.
What I was given. What was I given?
2.52 grams of
Yes, 2.52 grams of H2SO4. Each arrow is a step along your chart. All right? So I've got to go down to get to moles. So it goes on the what? Top or bottom? Bottom. What goes on the bottom?
What the mass is.
The molar mass. Whatever's in the center right there is what goes down there. Well, I need to find the molar mass of H2SO4. All right? So how many hydrogens?
2.
How many sulfurs?
4.
And oxygen?
4.
4. So 1, 1, 32. You're looking and finding these numbers on your periodic table. All right? So when you add all of those together, you get 98. All right? Here's that slide in your notes in Canvas in case you need to go back. So I've got 98 grams. All right? So I can put 98 right here. That's the molar mass of my substance.
Hey, why does it go there?
Because I took the bottom arrow, so I'm going to put it on the bottom of the chart. All right? And it's my first step. So 98 grams of H2SO4. And that's how many grams are in what?
1 mole.
1 mole, right? That's our base. Remember, whatever our empty boxes is going to be 1 mole. Now that means that I've made it to moles. Here's my second step. That's why I have another line. That's my second step. And I'm going to take the what? Top or bottom?
Top.
Top. So that means it's going to be written in the top. And what gets written in the top?
6.02
6.02E23. All right, so when we look at this, remember, what is the key of dimensional analysis? Whatever goes up must come down. So my grams cancels, and then my moles cancel, right? So mole, and I'm left with what?
Particles.
98 times.
What unit am I left with?
Molecules.
Particles or molecules, interchangeable, right? Molecules. So here's the table that you should have. Here's it showing your units canceling out. You're going to need this again for physics, dimensional analysis, unit conversions. All right? So, multiply straight across the top. You're multiplying your 252 by 1 by 6.022. And that gives you your top number. And then the bottom, 98 times 1 gives you your bottom number. Now, what do I do with these two numbers? Multiply across,
Divide.
divide. So, determine the number of H2O molecules. So I need to determine what? Molecules. That's what I want to find. And I'm given what?
Grams.
3.26
Grams of water. So that's my given. All right, so here's what I have here again. I'm going from grams to moles and then moles to Pam. So go ahead and set up your table. What always goes in the left?
Given.
Yep, so 3.26 grams of H2O. And as soon as you have an arrow, that's when you need a new conversion table, all right? Conversion factor, so that's when you draw a line. Here's an arrow, I need a line. And on the what? Top or bottom gets me there? Bottom, so on the bottom I write the what?
Molar mass.
Molar mass of the molecules. Remember we have 2 hydrogens, 1 oxygen. Hydrogen is 1, oxygen 16. So 18 grams goes on the bottom. Another way you can remember that is because I need my grams to cancel out so that I can get to my final unit, right? So there's 18 grams and how many moles?
1.
1 mole, because that's where I'm trying to get to. Now that I've gotten to moles, I need to take another arrow, all right? You take another path, and on the top or bottom? Top, I'm going to put what?
Oh, this now makes sense.
Yeah,
6.022.
All of a sudden it just clicked.
Good. That is what I love to hear. Molecules of H2O. And there's that many molecules in what? 1 mole. All right, so again, we need a mole at the bottom because I need to cancel these moles, and now I'm left with, look, that's what I'm trying to find, right? That is my find, molecules of H2O. So here is what you should have. All right? There's my units canceling out. These green lines are not canceling the numbers. They're showing you that your units are canceling. One goes up, one goes down to cancel it out.
Mine didn't.
All right?
It's not finished.
And so multiply straight across the top. So that means multiply all the numbers on the top and multiply all the numbers on the bottom and plug them in top and bottom.
Okay, this
Rounded it off. So here is your final answer. All right, this answer comes from dividing these two numbers. This is just rounded. You have a whole bunch of decimals there. You're just going to round it off. All right, next example. Calculate the number of what? What do they want to find?
Grams.
Grams. That is my find. In what? That many molecules. That is my given. I want to find grams given molecules, which is Pam. All right, look, I'm working with grams. Do I know the formula for sodium bicarbonate? Did they give it to me? No, but I'm going to need it, right? Because grams means I'm going to need to find molar mass, right? Because that's the conversion for it. So let's go ahead and do that. Sodium is what? Na. And bicarbonate is what? HCO3. And what is the charge of HCO3? All right, so Na was +1, HCO3 is -1. Those cancel out, right? So now I just need to add all of my masses together. Na is what?
23.
Hydrogen is? Carbon is? And I've got 3 oxygen, so 16 times 3.
Wait, why did you do that first? Oh, we're just calculating.
We need to find the formula in order to calculate.
This is just a part of what we have.
Yes, because, I mean, we could do this later on. You could do it when you get to that box in your problem and go, oh, wait a minute, I need mass. But we just said, hey, I know I'm going to need it because it says grams, so let's go ahead and find it. So add these together, and what'd you get? 16 plus 16 plus 16 plus 12 plus 1 plus 23.
40, 80, 84.
84. All right, so
This one.
here is your mass. And I set it up like this in the notes, but yesterday when I did it that way, people were like, whoa, where'd all these multiplications come from? So that's why I listed it out. All right, so 16 times 3, 12 times 1, you can do it that way if that works in your head instead of listing it all out, but I don't want to lose anybody finding that. So I'm going from molecules to grams. I need 2 paths, right? So let's go ahead and draw this out. What did they give me? 3.54 E25 molecules of NaHCO3. NaHCO3. All right, and my first step is to go what? Top or bottom?
Bottom.
Bottom, and I need to put what?
6.02, 23.
6.02 or 6.022, same thing, just rounded different. E23, because there's that many molecules in what?
1 more.
1 mole of NaHCO3, sodium bicarbonate. So 1 mole. And then from there, I go to what?
1 more.
I'm at mole. I need to get to grams. So what do I put?
More mass.
And it goes on the top or bottom?
Top.
Top. So that's that 84 that we just found. So 84 goes on the top, NaHCO3, because in 1 mole, there are that many grams. So those are our unit conversions. So your table should look like this. All right? Here's your units canceling out, molecules, molecules, mole, and mole, and you're left with grams, because that's what I'm solving for. So multiply across the top. So that means all the numbers on the top, 3.5 times 1 times 84, 3.5 E25. Multiply those together, and you should get this top number. Multiply the bottom together. Well, it's just times 1, so you should get this bottom number. All right? And then divide, and you have your final answer. Awesome. Everybody, does it make sense? Are we doing good? Doing good?